All right, here we go. Bear with it. Boop, here we are. Hey, what's up, Wes? This is your video on the difference of two squares. And for you and anyone watching it, this is kind of an introductory explanation of how you go about factoring out a binomial where the first and the second term they're like squares. Now, in this particular word, all of it is color coordinated. So the yellows will refer to the first terms and also the first terms of the answers that it factors out into. And the green is going to be the second term that it factors out into as well. The blue will be what I call the pre-factoring. So in this particular unit, you have to look for common factors in the binomial that you pre-factor before you get down to the nitty-gritty of separating two squares. Now, there is also a factoring, what I call a double dipper, and I'm going to go over that in the later half of this section because it wasn't on the homework, but I know with 110% certainty that that will be there. So bear with it. You watch this video, get the rhythm down, and then I'll show you that little difficult part that will be on the test, like 110%. So we look at here at number one, and what we have here is k squared minus 100. Now k squared is a square, and so is 100. And so what we have to do is kind of peel our eyes and let our eyes start looking for squares in letters. And one way you know it's a square in a letter is that the exponent is even. And I'm going to explain that concept in a second. So anytime you see a letter with an even exponent, for example, if I have x to the 16th, well, that equals x to the 8th squared. So anytime this number is even, you just have to divide it by 2, and that's the square root of it. Another example would be like x to the 6th. If you square root that, that equals out to x to the 3rd when I square root x to the 6th. All I did was take the exponent and then divide it by 2, and that gives me that. And you're going to be utilizing that in different problems. So for example, if I had x squared minus 25, well, that's easy peasy. That's going to equal out to x plus 5 and x minus 5 accordingly, right? But let's change this 2 into a 4. And so we'll look at something like x to the 4th minus 25. Well, everything is essentially the same, especially if you look at the second term. The negative 25 on both of our beginning binomials will still conjugate into positive and negative 5 like so. So in the two binomials that x to the 4th minus 25 turns into, you'll have a plus 5 and a minus 5 for the second term. However, since this exponent is negative, or no, since this exponent is an even number, it's going to be the exponent divided by 2 for the first term of those two binomials that it factors out into. So in this case, it's x to the 4th. So therefore, each term is going to be x to the 2nd. And that is going to be an important principle in this particular unit. All right, looking at number 2, it's the same thing. 81 is a square and r squared is a square. After square rooting 81, you get 9. And after square rooting r squared, you get r. So pop-de-pop and boop-de-boop, you get the conjugates 9 minus r and 9 plus r. And when I use that term conjugate, all that is referring to is opposites. Whoa, there we go. Is opposites. And what's opposite is the negative and the positive in the binomials. The other terms remain the same. Just get ready for next year in chemistry when I'm going to have to utilize that word one more time in your high school career. And you will only see it a second time in your high school career in chemistry when you deal with conjugate bases. But for right now, you just need to know anytime you see the conjugate of something, what you're learning is like opposites, or they almost complement each other as opposites. So there's not a negative connotation on that. It's just opposites. All right, here we have 16p squared minus 36. And what we're going to look at is the 16 and the negative 36. I'm always going to pull the greatest thing out of it, and they have a greatest common factor of 4, so the 4 gets pulled out from both. And then 16 divided by 4 is 4, and negative 36 divided by 4 is negative 9. Now we get into a position where there is a difference of 2 squares because the square root of 4 is 2 and the square root of p squared is p. Since they're factors of one another, or they're not, one is a coefficient of the other, everything gets to work within the same term. So square root of 4p squared is 2p. And then negative 9, or 9 itself, the square root of is 3, and that's why it splits into 3 and 3. Again, the factors are going to be conjugates of one another, so that's going to be 2p plus 3 and 2p minus 3. Moving on to number 4, there is a thing that they're trying to block you on, and we do have a square there. We do have a square in 25, so 4x squared and 25 are both squares, but the issue is that we are adding it, and therefore it is history. We can't factor that anymore. But later on, when it's cubes, you can. So I want to make a small differentiation here, is if it was the addition of 2 squares, this is no bueno, can't do anything. But if it was the addition of 2 cubes, like this, for example, you can do something, and we're going to discuss that in literally the next section after the test. So I don't want, I'm saying this now so that way you don't create a permanent block whenever you see 2 binomials in this unit and they're being added. It's only when they're squares. So if this is a square, 2 squares that are you're asking for the sum of them, they cannot be factored. Got it? Cool. So moving on to number 5, we have 16 minus 4f squared, which is easy peasy as well. The square root of 16 is 4, and 49 square root is 7, and the square root of f squared is f, and everything goes accordingly. So that one, you didn't have to do any pre-factoring. Of course, on this one is that little small double check, because like on something like 3, you have to pre-factor, and something like 5, you don't have to pre-factor. A good indicator for this unit is if you see the difference here, and this is a square, but this one's not a square, because the square root of 16 is 4, so you got a square there, but this one's not, more than likely, I want your brain to go in the direction of this pre-factoring. You'll have to pre-factor if you don't see the and then if you factor it out and it doesn't equal out to a difference of 2 squares, then you factor it as far as you can go. So one of the trick answers on this is after you factor it out. So let's say you have something along the lines of, I don't know, 50x squared minus 30. And you factor out a 2, like so. So I look at this, boom, boom, and I factor out a 2. What's left in the binomial is 25x squared minus 15. And you are done. Because if you see 25x squared, this is good to go. This is a square. I'm good to go on that. And if I could factor that out into 5x as the square root. However, the problem is like after you factor it out, what in the world? Hold on. A little technical difficulty. There we go. The problem is after you factor it out, you get a negative 15, and this is no bueno. You can't factor that out. That is not a square, and so at this point, you're done. So there are some times when you do some pre-factoring, and after the double check to see if it's 2 squares, it doesn't work out. So you're done after that. But on everywhere here, like on number 8 where there's a blue, you definitely have to the pre-factored results in the difference of 2 squares. All right, moving on. What we have here is on number 6, 36g squared minus 25. This one's self-explanatory. 36 square root is 6. Square root of g squared is g. And square root of 25 is 5. Number 7, same ordeal. Square root of 121 is 11, so that becomes the first term. Square root of m squared is m, so that's also part of the first term. Square root of 144, 12. Oh, oops. That one's supposed to say 12p. right there. All right, and we got it rolling with the square root of p squared being p. On number 8, once again, we see that the most common factor between the two terms is 8. So I'm going to pull out an 8 from 32 and 8, that's indicated by the blue. And it leaves us with the difference of two squares of 4 minus y squared. Square root of 4 is 2, pop, pop. And square root of y squared is y, pop, pop. Moving on to number 9. Between 24 and 54, they both have a 6 in common. If you have trouble finding out what that factor is, keep factoring out. So obviously, one of the first ideas that you can get from this is that they're both even numbers. So let's do an alternate route where all I did was pull out a 2. So if I pull out a 2, 24 divided by 2 is 12. And 54 divided by 2 is 27. So it would look like this. Now, I'm not done factoring. First off, neither one of them are squares. And I'm not done yet because I didn't factor all the way. So earlier when we mentioned after factoring out, and it doesn't give you the difference of two squares, that you're done. And yes, this isn't the difference of two squares yet after I factored something out. But note that you might have to keep going because between 12 and 27, it does have a 3 in common. So after pulling out the 3, then we're back into a difference of two squares situation because 27 divided by 3 is 9 and 12 divided by 3 is 4. And so pop, pop, we got that. And then we move here to 2. That was previously factored out. And then finally, you're just back in the same position because 2 times 3 is 6. And you got the difference of two squares here. So the square root, now I can just simply do the square root of 4a squared, which is 2a, and the square root of 9b squared, which is just 3b. Bop, be bop, and we are donezo with that one. 10 is very similar to number 7 here, where I just have to take the square root of 121t squared, and that's 11t. Square root of 64u squared is simply just 8u. Moving on. Number 11 is literally the same idea, where we have the square root of the second term, 100, that equals 10. And then we have 9d squared square rooted into 3d. 12 is the same thing as the other ones where you pre-factor. There we go. There's my green. No, let's do red. Pop, or no, not square root of 36, but you can't. Now here's, let me pause here on number 12. This is a square, 36, and this is also a square, number 9. But there is an issue here that this is an odd exponent, and this is also an odd exponent. When it's just a z by itself, there's an understood z to the first there, so that's also an odd exponent. And that is not a square. So it makes it so that way you're close, right? And this is where it gets a little confusing, but you should feel something here. The fact that they have a common term here and this is odd. You're not done yet, and you have to keep working with it. I think what a lot of students may accidentally do is pull out just the z, and then you end up with 36z squared minus 9. And that turns into a difference of two squared that way. So let's take that alternate route. Like this is the straightforward route where I just pulled out a 9z, leaving me with 4z squared minus 1. And that is the difference of two squares because 4z squared turns into 2z, and then square root of 1 turns into just 1. But let's pretend like you're frustrated with this, and we have an alternate way. So let's rewrite it here as 36z to the third minus 9z. And let's say, oh, I'm going to pull out a z. And then after that, it actually does turn into the difference of two squares after pulling out just the z. So just the z was factored out, and all the other terms stay the same. And you do factor this out as the difference of two squares. Let's look at the first term as 36z squared. The square root of that is simply 6z. So you end up with the 6z plus something and a 6z minus something for your factors. Once again, the z just drops. And the square root of 9, as we've been doing it throughout the whole entire thing, is 3, or since the dawn of time, the square root of 9 is 3. And we have a 3 and 3, and we are good to go. Now, you should be good to go. I mean, it feels like you're okay. But on this particular test, you're trying to get the full factorization of everything. We're not fully factored out because neither one of these is the difference of two squares, so we already did our part. But they're both divisible by 3, so I can pull out a 3 from this first binomial and a 3 from that binomial. And all of these terms are now going to be multiplied by this coefficient that we pull out from each individual binomial. And 6 divided by 3 is 2, so that gives me 2z. And 3 divided by 3 is 1, so pop 1. 6 divided, and we get the same exact result here, except we get 2z minus 1. Don't forget to drop the z that was there. Then we multiply all the coefficients together. The 3, and the z, and that will all come together to make a 9z, with the two binomials just dropping down, 2z plus 1 and 2z minus 1. So do you see we end up with the same result as here with the full factorization of it, but your brain can go in two separate directions, and as long as you keep true to the principles of this unit, you'll be able to maneuver through it and get to the same answer. So if you get down to this position, you will commonly feel like you're done right here, but if you put this on the test, you will lose points on it. And that will be the difference between someone making a B and an A on this test, is that little small minute extra check. Moving on, number 13, boom, boom, they're both divisible by 5 and divisible by q. So we pull out a 5 from 45 and 20, giving us 9 and 4, and a q from q to the third and q, giving us q squared and 1. This part right here is just easy peasy. You got 9q squared, square root of that is 3q, and the square root of 4 is 2, and you're donezo after that. Neither one of these binomials is factorable, like in this position in the example, so you're done. Number 14 is redundant of the same thing, square root of 25b squared, 5b, square root of 9 is 3, and 15 is also factorable of 3 because 3 times 16 is 48. Let's go over something here too, that we are feeling like we're in a very similar position to factor this out in some way or form. And to know that 48 is divisible by 16 is not common knowledge, because everyone at that grocery store, when they do flashcards for the kids, everything stops at 12. So most people only know the factors up to 12, right? And so we're here at 48/16. How are you supposed to know that? Well, look, you see how there's a 3 here? And on some of these parts of the test, you may not be familiar with all the factors of everything that can be pulled out. But experiment, okay? So if there's a 3 here and a blah right there or anything, but you can already feel like these are common things you have to pull out, test that other number to see if it's divisible by that number, by the first one that's being pulled, or the prime number that's there. They will have something in common. Or here's another example. Let's say I have 25x squared minus, or 50. Here's an example of 50x squared minus, I don't know, 128. Now, you already can feel something here that to get the difference of two squares, that I can pull out a 2, and that gives me a 25x, 25x squared. And your feeling in this position on the test is this is good. But what about 128? I've never seen that before. Follow your heart and pull out the same 2, and it will usually lead to something that is more familiar with you. I'm not going to sit here and tell you to memorize factors from up to 16 on the multiplication scale. If you don't know it, it's fine. You just have to have an explorative, experimental spirit when you take this test. Do not quit on it just because you don't see it. Keep going and find that factor. So after pulling out a 3, we're now in a common position of t squared minus 16. Square root of t is t, square root of 16 is 4, and it factors out into the difference of two squares. Now I'm going to go into something that was not on this homework that I do need you to know, because on this test, it's 100% going to happen. On your notes, I want you to write down the double difference of two squares. The double difference of two squares. This is when it factors out into two binomials twice, and it is definitely possible. So let's say I have an even number exponent for x to the fourth, and I'm going to subtract y to the fourth. They have an even exponent, so they're definitely the difference of two squares. And so the first one would be x to the fourth plus, or not x to the fourth. The square root of x to the fourth is x squared, so that'd be x squared plus y squared, pop, pop. And the second one would be x squared minus y squared, pop, pop. So boom and boom. Things like we're done, right? But look, after we factor out the first x to the fourth minus y to the fourth, one of the conjugates is another difference of two squares. This is another difference of two squares. And therefore, we're done on this one because this is a sum. And as we mentioned earlier, whenever there is a sum, we're done. There's nothing left to do after that part. But this one, we keep going and it splits yet again, because the square x squared square root is x and y squared square root is y. And now you're done after fully factoring it out. And I call this the double difference. Some indicators that you're dealing with the double difference is that you have a square exponent higher than 2. So if it's 4, 6, or 8, you're definitely going to have, or this is an even exponent that's higher than 2. You have to have a 4 or an 8 or a 16. It has to be somewhere along the lines of that. Now, this is definitely one of the more common ones where you see a 4. I rarely see the 8. It's going to be the variable is going to be to the fourth power. Now, let me add some numbers, and it's usually these numbers only. Write down for double difference, underneath the double difference, put coefficients of 16 and 81. 16 and 81. 100%. These are the things that give you the double difference. So if you come across these numbers with something with a variable to the fourth power or to the eighth power, then it's a double difference. And let me show you an example of that. Let's go ahead and go all the way with it at 16x to the fourth minus 81. And the reason why it's a double difference is because we square root the first term, and that gives us 4x squared plus 9. And this is going to give me 4x squared minus 9. Because if we look at the 16, the square root of it is 4, and 4 is another square, because that can split out with a first term of 4x. And the square root of 81 is 9, but 9 is also a square root. Scam lightly at 7 o'clock. Wow. They're pretty adamant. All right. And the square root of 9 is 3. At this point, you are done. Remember that this is the sum. Can't go any further than that. So it just copies right down. And so this is the heart of what will be on that test. Now, I'm looking at your unit, and they didn't cover this with full aggressiveness, and that scares me. And so I've been doing this a while. I know this is going to be on that test on Wednesday. So watch this video, get a good firm grasp of the difference of two squares, and kind of like look out for if it's a sum, you can't do anything more. If it feels close to a square, It probably is, and you just have to keep factoring out. Even if you don't see the factor right away, like here on number 12, 9z was the factor, you can still do it incrementally, one by one, as long as you're keeping track. So the key here is these long ones. If all the tests was something like number, like number 6, where it's just one layer. Look at how number 6 is just one layer. Those are easy peasy, and those are only going to be about 60% of this test. The rest of this test are going to be questions like 9, where you have to do some pre-factoring, and 110%, you're going to look for 16s and 81s to get the double difference of two squares. Again, the double difference is when the square root is another square, and it only happens with 16 and 81. Like if I use 25, the square root of that is 5. This is already done. Or like 49, the square root of that is 7, and that's already done. The issue is like 81, when you square root it equals 9, which you could square root again, and that equals 3. The square root of 16 equals 4, which you square root again, and that equals 2. That's a good indicator that you're dealing with a double difference. And with that, that covers the entirety of the difference of two squares. So I'll be back on Monday, and from there we'll be able to rock and roll and really chisel out this skill set. Mind you, a majority of the people are not going to do well on this test. And it's not because people are dumb or whatnot. It's just the dynamic of the classroom rarely goes into like the nitpicky part of that double difference, and also how to not give up whenever you're factoring out before you get to the difference of two squares. So, all right, man, you take it easy, man, and I'll catch you on Monday.